A little known fact about Albert Einstein, the man renowned for his groundbreaking contributions to science and mathematics, and often hailed as the greatest scientist to ever live, is that his father actually originally intended for him to pursue electrical engineering, a career that was deemed stable and prestigious at the time. However, when a young Einstein stumbled upon a compass and realized that there was more to the world than meets the eye, he realized that he had a destiny to pursue and explain the inexplicable. Now, although I didn't have nearly as stage-worthy of a eureka moment as he did, I can still pinpoint the exact experience that led me to my field of study today, quantum astrophysics. Growing up in a traditional Indian household, I learned Hindi before English, with my parents assuming that English would just be taught in schools, as it was for them in India. However, this assumption quickly proved to be wrong when my kindergarten teacher, looked at me in confusion as to try to speak to her in my native language. Now, I picked up a few phrases here and there to manage basic communication, but my parents knew more drastic measures had to be taken, and they saw poring over books as the most optimal strategy for me to catch up in terms of my literacy skills. The first book I ever read was National Geographic's Science Encyclopedia of Everything. Okay, well, to be honest, the first book I ever read was The Very Hungry Caterpillar. But, nevertheless, the Science Encyclopedia was one of the first books I ever read, full of colorful visuals and amazing facts that I loved sharing with family, friends, or really anyone that was around me. One section that really stuck with me, though, was the space chapter. Learning about planets and stars was the most surreal experience I'd ever had. Describing objects so immense in size and alien they barely seemed real. Now, as I got older, this passion developed, refined, and manifested itself into a fascination with the realm of astrophysics, particularly in the field of particle physics. To me, these fields represented the cutting edge of human knowledge, constantly pushing the boundaries of what we understand about the cosmos and our place within them. It is thanks to this deep passion that I was able to explain to myself and teach myself concepts like this, which represent the most fundamental principles of how the world operates. However, I understand that things like these might not make the most sense to everyone. Unfortunately, in today's world, there aren't really any simpler or more approachable ways into this field. As a result, theoretical physics is often perceived as having a high barrier to entry, discouraging many from pursuing it. But here's the thing. I believe that these concepts aren't as impossible to understand as they're often made out to be. Let's take a quick moment to describe some of the most fundamental concepts in this field. At the core of our understanding of the universe is the standard model of particle physics, sort of like the periodic table of subatomic elements. The standard model is split into two categories: fermions, which are responsible for all of matter, and bosons, which govern the interactions between fermions. These interactions are known as the four fundamental forces of nature. For example, electrons, which are inside atoms, are fermions, while bosons, which you can find an example for by photons that carry light, would be bosons. Each particle, regardless of type, fills our world in the form of fields. Think of fields like invisible grids that stretch out across space, with each individual layer representing a different kind of particle. Now, whenever there is a disturbance or a ripple in any of these fields, kind of like a wave moving through water, it appears to us as a particle. So what we perceive to be particles are actually just tiny vibrations or fluctuations in these all-encompassing fields. At scale that is so small, Newtonian motion, the kind we learned in high school, no longer applies. Instead, particles exist as a gradient of probabilities, with their exact positions and momentum remaining unknown until calculated. This is why electrons don't actually follow the neat, circular, planet-like orbits we're used to, but instead form a diffuse cloud, with the darker blue of the Schrödinger model on the right representing a higher likelihood of finding a particle at that given location. Now, I understand that these concepts might not make the most sense to everyone, and a lot of you don't share the same passion for physics that I have. But that's kind of the beauty of humanity. Each of us has our own paths, hobbies, and interests for making a meaningful impact on the world. The famous stockbroker Warren Buffett once said, "In the world of business, the people who are most successful are those that are doing what they love." And I'd like to extend this to all realms of human endeavor. The people who excel the most are those that are driven by a genuine curiosity and love for what they do. Too often, society expects us to do what is safe or expected, like becoming a doctor, a lawyer, or an engineer. While these are all undoubtedly very valuable professions, they're not for everyone. When you follow a path simply because it's expected of you, you may never reach your full potential. So my challenge to all of you sitting here today is this: find what excites you. Whether that's coding, design, music, or anything else, what matters is that it brings you joy. Pursue it relentlessly, even if it may seem difficult or unorthodox, because when you're truly passionate about something, the obstacles will feel more manageable. Einstein once said, "The important thing is to not stop questioning. Curiosity has its own reason for existing." It's those who dare to venture into the unknown who ultimately change the world. Thank you.